Okay, great. I think it's about time we start. Firstly, I'd like to thank everybody for signing up today. We've had great interest from the industry and looking at the attendees, that it's a truly global representation from the US, from Canada, from Europe. Seen some guys from South African wind teams signed up as well, and quite a few from Asia as well, which is great to hear. So thanks a lot for signing up. So the webinar today is looking into wind and storage, transition into dispatchable production and management. And I just quickly want to introduce the speakers. So we have two speakers from GE Renewable Energy, Amelie Wolf and Juanita Ajadeda. And also we have Martin Hubers from DNVGL. I think it's best if they could give a quick background on their roles and also their companies. So Martin, if you could take it away from your side at DNVGL.
Yes, thank you, Reese. So my name is Martijn Huibers, working at DNVGL in Arnhem, the Netherlands. I'm leading the energy storage team here in Arnhem of about 10 people, part of a broader department in the EMEA region, so let's say the northeastern part of Europe, but also covering Africa and the Middle East. We cover advisory and testing services on energy storage as an independent third party. Things like owner's engineering, due diligences, but also testing, safety reviews, verification, and training. So we're really involved. If you look at it from a project perspective, a storage project perspective, we're involved from the feasibility stage through procurement, commissioning, testing, up to the end of the project. We're supporting our customers there.
Great, and the team from GE?
Thank you, Reese. Hello, everyone. My name is Juanita Ojeda. I'm the strategic marketing leader for GE Renewable Hybrids. I've been with the company for 6 years. Before that, I worked in the oil and gas industry with Colombia's national oil company. I've been part of the hybrids team for around 1.5 years when we first started looking at hybrids as an initiative and part of a center of excellence within GE Renewables. And I now lead the marketing team in the new hybrids business that was created in March 2019, which now incorporates our storage, solar, and integrated solutions businesses within a single P&L. Amelie?
Yeah, hi everyone. Yep, thanks Juanita. Hi everyone, my name is Amelie Wolf. I lead global sales for what we call integrated solutions within the, as Juanita pointed out, recently established formal business unit of renewable hybrids within renewable energy. I have a kind of cross-product technology focus, also for a particular region, which is EMEA plus India. So they are basically cover all pieces of the renewable hybrids offering, which I believe we talk about in a minute. Have been with this topic, have been with hybrids probably one of the longest within GE Renewable Energy, and as such, always happy to talk about it. Back to you, Reese.
Great, thanks guys. So as you can see, we've got a really specialist panel today for this topic, and how it's going to work quickly. First, DNVGL are going to do a quick 15-minute presentation, and then GE will do a following presentation, and then we'll take all of the questions for both and the topic in general at the end, just so then we get a good spread and we can sort of open up the conversation between the presenters and the panelists. There is a question function, as you can see in the control panel for all listeners. So make sure to get your questions in throughout, and we'll be speaking about them for the last portion of the hour. So I'd like Martin to take it away. If you could share your screen. I've just sent you the notification. Great. Okay. Yep. Looks good.
Yeah. So thank you, Reese. Hello, everyone again. I would like to talk about renewables plus storage, wind, also a bit of solar and storage, and especially what we as DNVGL foresee, forecast actually that's going to happen over the next decades, and also some of the experiences we already have at the moment. So the first bit I'll do based on our energy transition outlook. So what is that? We have launched the 3rd edition of our energy transition outlook a short while ago. It's a global and a regional forecast of the energy system up to the year 2050, 50. It is not a scenario, but it is a forecast. So we have built a very elaborate model with inputs like technology developments, cost developments, these kind of considerations. We've just modeled up to the year 2050 what that would mean for things like energy use, the energy mix, uptake of electric vehicles, energy efficiency, these kind of things. And some of the key highlights that we have seen in the latest edition that we have now are on this screen. So, one, rapid energy transition, but not fast enough. I mean, yes, we see a rapid energy transition unfolding within the time span of, let's say, a generation, but we believe it's not really fast enough to meet the Paris ambitions of staying below 2 degrees temperature increase globally. At the same time, we do believe, if we model this correctly, we believe that existing technology can deliver the 1.5 degree target. So, so we can move forward with, let's say, the essence of the technology that we have now. Another interesting finding, what we see is global energy use in our forecast peaks by 2030, which is unusual because so far energy use has been increasing only. I'll get more into that a bit later. And also, it will be affordable, we believe, because we foresee that a smaller share of the GDP will be spent on all the costs of energy. I'll get into that a bit more in a minute. So, how did we improve with those that are familiar with the energy transition outlook in 2017 and 2018? The key improvements that we have made, and therefore we're not just calling it an update, it's really a new version, are, let's say, an hourly model where we, of the electricity market, where we model the prices at hourly intervals. And also we've enhanced our modeling of electrification of the road transportation sector. So, yeah, and what I forgot to say is that if you want, you can freely download this ETO. It's freely available on our website. Even the data is available. You can also download that. It's available on our digital platform, Veracity. So if you want to look at the data in a bit more detail and use it for your business or your own interests, that is totally possible. So the ETO, just to finalize this bit, to give you context, it contains the main report. It's not light reading. It's not something you just do over a cup of coffee, but it's a lot of information. We are looking at different aspects. You can see them here, and I would invite you to take a look and also challenge us on the findings. So what I'll share, why am I mentioning this? I've shared this because it provides, the ETO provides insights that are very relevant when we're moving into we're going to take a look at the question of renewables plus storage. What is going to happen there, and what are the applications that we're going to see? So one thing that is relevant, moving gradually closer to renewables and storage, one thing that we'll see is that there is going to be a decoupling of GDP and population growth with energy supply and also related CO2 emissions. That's going to happen by around 2030, and that's actually a break of the trend of the last decades. Another interesting thing, so what I said here, the energy demand will peak by 2033, more or less. And you can imagine, you can wonder, why is that going to happen? Because the world population is going to get more and more access to technology. The population is still growing. Why would energy demand still peak? Well, what we believe is going to happen is that in principle, there could be, let's say, a raw demand increase, but at the same time, we have efficiency gains. So yes, there's going to be, you see that on this slide, there's going to be a growth in population, economy, service delivered, but we will gain a lot of efficiency in transport, and that is mostly due to electric vehicles, which will affect storage. And this is where we're getting closer to storage, the topic of storage. There will be efficiency gains in manufacturing, the production of goods, and there will be efficiency gains in buildings, basically the power and including heating of buildings. So that leads ultimately to a peak in between. So you see here 2017 and 2050. In between, it will peak, as I've shown on the previous slide. So if you take a look at electric vehicles, I mentioned it before, this is going to be a very important factor in the energy transition. It will lead to efficiency gains, because there will be less power spent less primary energy spent on transportation. But at the same time, it has a double impact on storage. One, it leads to technology development. The batteries that are required for electric vehicles there will be an enormous push, and we're seeing that already now, in performance increase, and also cost and safety increases. And this has a big impact on stationary storage that can and will be used for grid purposes. If you take a look at lithium-ion batteries, there are other types of storage, but especially lithium-ion batteries will benefit very much from that. And the other impact is that electric vehicles by themselves will be able to provide, let's say, services using their storage, using their batteries. There will be a vast amount of storage available in principle, available for grid purposes in the next decades. So when you look at electricity generation, you will see that the mostly fossil-fueled mix of nowadays is going to move to mostly renewables, and that is dominated by wind and solar. You see offshore and onshore wind in blue there, and in yellow solar by 2050. So this large share of renewables, it will require a considerably more flexible system. So storage capacity, if you take a look at the predicted storage capacity, it will probably be like 50-fold what is available at the moment. So that means if you take a look at the next 30 years, the storage market is going to expand dramatically. And is that really going to happen? Some of us are doubting. I've heard some of us express doubts with respect to cost learning curve. But when we looked into into the next decades, looking into what the drivers are for these learning curves of the key technologies. So wind and solar, as if you look at it from a storage perspective, wind and solar are enablers for storage, and the other way around as well, by the way. They still have a learning curve of 18 and 16% in our predictions, and storage itself, as I said before, very much driven by electric vehicles, will have a learning curve of 19% over the next foreseeable decades, basically. So there's still a lot to gain, in other words. Maybe there is, this is an interesting thing to mention as well. This is a residual load curve. When you look at, so from left to right, you see here a graph going from top left, so a line basically from top left to bottom right in this curve. On the left axis, there's the demand in gigawatts. But you can also, it's actually a residual load curve. So it's sorted from high to low, so from positive to negative. And the gray area is the part that is covered in 2050 in a representative country or location by fossil generation, or actually that should be more like dispatchable generation, which does not necessarily have to be fossil, but dispatchable generation. It could also be partially covered by batteries, actually. But the light green parts of the curve are renewable generation. But what you see, the interesting part on the right is the bottom, is the dark green part, and that is the part of the year actually where renewables will need to be curtailed because the demand is, there's more production than there is demand. And this is, of course, leading to, not the only, but it's one of the things that leads to demand for storage. So this is another example of the need for storage. These are two graphs of modeled graphs of the residual load in the Netherlands. The left one 2012, and the next one in 2030. On the left one, there's only very little PV and wind available, and in 2030 there's already a significant amount more like 8 or 9 times the amount. And you see, of course, that as expected, there's a much larger variation in the residual load. Therefore, there will be quite a lot more flexibility of different kinds required. And storage is not the only type, I'll get into that on the next slide, not the only technology or service that can provide that flexibility, but it's definitely one of the technologies that can do that. It's also not the only application of storage. For example, wind and also solar inverters, for example, will lead to could lead to voltage issues on the grid, and all this together could put pressure on the reliability of electricity supply. So it leads again to opportunities for storage. And here is what I said before. I mean, if you look at the required flexibility in the future energy system, it can be provided by flexible power plants, gas, for example. It can be provided by curtailment. It's not what you want, but it's definitely part of the solution, probably. It will be very cost intensive to cover the required flexibility to the very last second only with the other options. So it might be a part of the solution as well. Demand side management, demand response is going to be part of the solution. Interconnection, there's a lot of work on interconnection at the moment. And if it's definitely going to be an ingredient for that. But if you take a look at, for example, we've done some modeling on weather systems. There is a correlation, unsurprisingly, in generation in, let's say, local sites. And what I mean with local, let's say within a few hundred, let's say 500 kilometers, there's a strong correlation because weather systems may have that size that is roughly, may have roughly that size. So that means if you have a surplus of solar or a surplus of wind in a certain region, interconnection to across the border where it's only 200 kilometers away is not likely going to be a solution. So if you have a longer interconnector, of course, you have bigger losses as well. So interconnectors can alleviate the problem, but it will need to be a combination of all of these solutions. And factors or ingredients that influence this flexibility question are also new technologies that will increase energy use and also flexibility needs, but can also provide demand response and demand side management opportunities. And of course, as I said before, electric vehicles. So when you look at, getting back to the ETO, in this graph, you see the source and of the deviations of the, in other words, of the required flexibility, as well as providers, so technologies that could provide flexibility. And what we found was that when you look at what causes flexibility, there's flexibility, or let's say a deviation in demand, but also, of course, the generation that is not exactly as predicted. So to a certain large degree in solar, but also wind. And if you take a look at what will provide this flexibility, yes, there will be storage, which can offer a contribution, like battery storage, to a certain degree pumped hydro, EV storage, but there will also need to be, both from a cost perspective as well as from a technology perspective, a contribution from other generators. So again, like in the previous picture, previous slide, we will need to use a combination of different technologies to deal with the flexibility that we need. Now, if we zoom into storage, what will we use it for? I mean, I talked about flexibility in many of the previous slides, but it's not the only thing. In fact, there are many applications possible and also required from a financial perspective to make storage work. It's much more complicated than if you take a look at, for example, solar by itself. If you take a look at solar by itself, you have a PPA, you generate revenue via contracts. That's it. In essence, it's not more complicated than that. For storage, there are many applications. Depending on how you categorize them, there may be as many as about 20 fundamentally different applications in different parts of the power system. You know, it can be on the generation side, co-located. It can be in the high voltage grid. It can be in the medium low voltage grid. It can be behind the meters. That means that even for a given location in the grid, in the power and the energy system, basically, there can still be different applications. At the moment, I would say the most commonly viable application would be frequency containment reserve. So ancillary services, basically one specific type of it. That is, I would say, in most regions, the dominant application at the moment. But we're seeing more and more other applications as well. When you look at California, for example, in the US, ramp rate restrictions are becoming an issue where there's so much solar that when the sun starts to shine, the solar production in the grid is ramping up so fast that the grid cannot handle it anymore, or at the very least, it is outside of the requirements of the grid operator. That means that we need, for solar generation, you need a way to mitigate, to reduce ramping up and also ramping down. Storage can provide that, co-located storage. Ancillary services, there is in many countries that if you need to build a wind farm, you need to have a certain contribution to ancillary services. You could incorporate a storage system on your wind side to provide these ancillary services. Then there's time shifting of energy. Maybe you want to save your store the energy for a moment where the prices are higher, arbitrage, or when it can actually be dispatched onto the grid, or you want to place storage behind the meter on your, let's say, your industrial site, combine it with wind or solar there, and do demand charge reductions. So make sure that you don't have a high tariff. You reduce your maximum rate, maximum tariff from the power provider. And actually, we see that in storage applications at the moment, it's most common that there is more than one revenue stream applied, and I would say that is also because it's not possible in most cases to build a positive business case. In most cases, if you only have one revenue stream, there are several reasons for that. It's highly dependent on regulations and the market, and therefore also very difficult to give you now a general piece of feedback or a picture of how that is, because it's very much region dependent. It's also very much dependent on the grid situation. Are there parts of the grid that are overloaded? What is the energy mix? What about the flexibility already available in the grid? So it's fair to say that there are very many opportunities for storage, many applications that are actually viable, and I would say all of these are actually in commercial operation. Mostly ancillary services at the moment combined with something else, but depending on local situations, it can very well be that that there are other applications suitable. So, as I said before, the important factor that will affect the business case is where it is located. Is it going to be co-located? Do you want to do energy shifting? Do you want to do ancillary services, smoothing? Another application is quite important. Reducing curtailment, which is just lost money. Do you want to have it standalone? Doing arbitrage, ancillary services, capacity. Behind the meter. I've talked about grid scale storage mostly, but there are very many behind the meter, smaller, let's say commercial and industrial scale, or I would say residential scale systems as well behind the meter. That can be interesting from to be aggregated as well. Yeah. So one example of such a system that we've seen, we're hearing most attention for solar plus storage at the moment. And what we're seeing in the market, our customers are mostly focusing on solar plus storage, but there is increasing attention for wind plus storage as well, co-located. One example of that is the Vattenfall, it's former Nuon Alexia wind farm in the Netherlands, where a storage system of 3 megawatt is built, being expanded to 12 megawatts. Part of the 122 megawatt Alexia wind park. Actually, to exemplify the link with EVs, these are actual EV batteries that are in there. And at the moment, it's mostly used for balancing and FCR. But like with many applications, this was built with, let's say, flexibility in another sense in mind, flexibility with respect to application. It's quite possible, and I would say it's almost required in most of the systems that are being built, that you keep in mind that the application of the system might change over time. There are very few long-term contracts out there in storage. If you do co-location and you just have a hybrid site, you could have a PPA for the site as a whole, which means that indirectly you have a long-term contract. But if you have anything standalone, you might need to bid, or the grid situation might change so that your application will change over time as well. So you need to anticipate that when you're building a system. Last thing I want to say before ending this presentation is that we've seen quite a few. This is still a relatively new market when we're talking about grid scale, co-located, or also standalone storage projects. Yes, the technology, the predominant technology at the moment, or let's say that has the most attention at the moment, is lithium-ion batteries. And yes, the technology is out there for decades already. But if you look at grid scale storage, we're talking about a different, let's say, technological behavior, and also risk profile than if you're talking about lithium-ion batteries in appliances that are already decades old. If you suddenly talk about thousands of cells together, you need to talk about aggregated risks. For example, what happens if one cell fails? What happens to the entire system? And what happens if that system is part of a larger environment, like an industrial production site or a residential area? And how do we deal with these risks? So risks that we've seen in this not yet mature market is business case wise. Business cases are calculated for, let's say, a general application, while the final application is not yet decided. But of course, that really affects the business case. Market saturation is not taken into account. If you want to bid into a market that is interesting now, maybe next year, with all the attention and all the learning rate that we're seeing, that market will not be interesting anymore. It changes so rapidly that your business case might also change rapidly. Then there are technical risks, like especially centered around degradation. If you talk about lithium-ion batteries, how fast does the lithium-ion battery degrade? It depends on the number of cycles, the depth of the cycles, the average state of charge of the battery. And if you don't know your application, or if your application changes, then your degradation, therefore your lifetime, therefore your business case will not be as you expect. And another factor is that manufacturers are very reluctant to share this data. So we've seen manufacturers provide degradation curves for circumstances that were totally different from the circumstances that are likely to happen in actual operation. So in other words, how can you be sure that the degradation that is being provided to you is actually relevant for your application? Then there are contract risks centered around warranties, which conditions they're applicable, what is part of the system, especially if you talk about if you work with system integrators. It can be that cells, control software like the energy management system, the EMS, inverters, etc. They are, at the moment at least, quite often interchanged with new versions, new updates coming out all the time, which leads to issues there, technical issues, but also who's doing what. It might be a cheaper solution to do it that way, but there are risks involved. Regulations are a very big area. Up to, I think, like 3 years ago in the Netherlands, it was technically possible for a storage system to participate in the FCR market, but it was legally not possible because such a piece of equipment that would participate in that market would need to be available by regulations for 24/7. So that means there was no period allowed in which it would charge. Therefore, it would disqualify by definition a battery. And these are, let's say, sometimes maybe you can call them archaic rules, but we are suffering from that. Double taxation is another obvious issue. And of course, there are systems that are not meeting standardization. It's quite unclear for many technologies, also, for example, flow batteries, what the standards are that are out there. Do they apply to all the things you need the quality to be high of, or the risks to be mitigated? And is it really certified? Has it really been checked? This is an immature market, so there's still a lot to be learned there. And of course, especially for lithium-ion batteries, safety risks. Fire suppression is a very big thing. I'm not saying at all that it cannot be solved. It can certainly be solved. These systems can be safe for operation, but we're seeing a lot of different players with different approaches, from very, very safe and to, I would say, more, let's say, higher risk profiles out there that may be suitable for if you place a system outside in the field and it burns down, that's okay. But if you want to use it closer to civilization or your industrial factory where you don't want to have a production loss, then maybe you would need to have more fire suppression or let's say safety measures taking place. So yeah, finalizing, I would say there are many opportunities for storage brought on by the energy transition and the changes that we foresee or forecast in renewables, solar and wind over the next decades, also brought on by electric vehicle developments over the next decades. There's a variety of applications that storage can be used for and will actually be very useful for. And generally, we need, at the moment, more than one application for the business case to be viable. It's very location and regulation dependent. And at the moment, there are quite a few risks that need to be looked into, but they can actually be mitigated. So there are no showstoppers from our perspective, but it's just something that needs careful attention. And with that, back to you, Reese.
Great, thanks a lot. Some really interesting visuals there and some great information. Thanks a lot. And there's been a lot of questions coming in. Keep them coming, and we'll get to them at the end. But in the essence of time, if I could pass over to the team at GE. I've just sent you a notification to share your screen.
Yeah, thank you. Thank you, Reese. And we'll try to catch up here a little bit.
No problem. Your microphone's muted, I think.
Juanita, can you just go on to the next one? Next slide. Yeah, maybe for the
Great.
benefit of everyone on the call, just a quick explanation of what we actually do within Renewable Hybrids, in specific, and more specifically in the integrated solutions segment. Basically, what we're doing is we're bundling together generation sources, renewable generation sources with one another. So you think wind and solar, hydro with floating PV, PSP with wind, storage with wind, solar with storage, and any kind of combination that you can think of in terms of renewable generation assets with one another, and or some kind and type of storage going along with it. We do that under the umbrella of an integrated system controls scheme, which is effectively a supervisory, high-level supervisory system for the controls of the entire asset stream. So not at the individual asset level, but in fact at the farm and at the hybrid power plant level. And last but not least, obviously, if and where there's economic reasons to do so, and the regulator actually approves to do so, we do try to integrate storage as much as we can. And again, clearly, particularly if and when there are economic benefits for our customers, who largely are developers and or existing or soon to be wind, solar, hydro asset owners. All in all, what we're trying to get to effectively is, and this is a bit of a long shot, but nevertheless, that's what a mission is for. We do try to make renewable generation assets less variable and in fact more like a baseload generation asset. Obviously, again, that's where storage plays in big time, and not necessarily just battery storage, but as I said before, any type of storage. So again, pump storage or in certain instances in countries in the world, even thermal storage. Juanita, can you go on to the next page? When we talk about storage being integrated with wind, I'd say we see it largely today being deployed in areas where customers are suffering from large chunks of curtailment. So the application of storage for curtailment capture is obviously one big element, and that is to drive and improve project economics. We also see if and where the regulation allows for such, and we actually also have remuneration schemes in place. We also see deployment of storage for the sake of providing grid services to the grid and thereby enabling an additional revenue stream onto the developer slash asset owner. We also see it though lately, and in fact lately even more so, to come across as the flexibility enabler. And flexibility enabler in the sense of people using storage to shift loads of energy from low price environments to peak price environments or higher price environments. So this notion of playing in the arbitrage opportunity is certainly something where storage comes in. This is particularly relevant in markets and environments where you have a lot of intraday wholesale price volatility. So where you do have large intraday spreads in between low prices and high prices, or so-called peak prices. There are certain markets where you see spreads beyond $100, and obviously those are markets which have been fairly interesting. And where we're seeing quite a bit of storage being deployed. So you go to certain ISOs in the US, you go to Australia, obviously, you go to even places such as South Africa, where again there's lots of swings, not only intraday, but even more so also from a seasonal perspective. And then there's one asset, the one kind of application that we see storage coming along more and more these days, and that is around providing a firm load to an off-taker. Obviously with wind and solar, you're already firming a generation profile quite a bit, but it may not necessarily, even in that instance, be always matching the load at the point in time when the customer is consuming that load. And battery storage in particular works very well to basically have a little bit of buffer for periods when wind and solar are generating insufficiently against a certain load, and you basically cover the rest of the balance of the load needed from storage, and vice versa. There are points in time over the day when wind and solar would overgenerate, and you would basically then use the battery storage asset to buffer and put everything that's generated in excess into the storage asset and deploy it when we have undergeneration. So again, that notion of load following and adhering to a certain load profile and using battery storage for that is certainly something that's coming up more and more. And again, I think where this plays, well is again in markets where off-takers suffering either generally very high prices, energy prices, retail prices, and or a lot of volatility within the wholesale price, which they obviously want to take out and have a bit more of a predictable energy price with a firm PPA behind it. And that firm PPA certainly can be enabled with a combination of wind, solar, and, as I said before, battery storage. Juanita, can you go on to the next? One area where we're also seeing storage being discussed recently more and more is obviously in the offshore space. There have been, I think, just even recently, particularly in the US on the East Coast, a few RFPs where the tender issuers have put in a requirement for bidders to come along with storage. Whilst in the RFP documents, that's not necessarily always yet been rewarded and remunerated, we do see those requests, and it's a bit of a qualitative element rather than a quantitative one. And the reasons we see storage becoming more relevant also in the offshore space is for three kind of buckets. One is obviously for the provision of so-called island mode capability, and all that basically is that you have storage replacing, for example, diesel generators. In the case when the offshore wind facility would be disconnected from the transmission line and basically be running on its own, you do want to have, and traditionally diesel generators have been doing that job. You do want to have a backup generator that's basically allowing the offshore facility to kind of keep running and kind of be self-sustainable with a conventional generation asset. And obviously, given the cost of diesel generators, there's more and more offshore developers that are considering, hey, is it worthwhile replacing that conventional generator, possibly with battery storage, again, for the sake of, you know, being self-sufficient in case of outages, disconnection from the grid, disconnection from the transmission line. And that's what we're seeing there quite a bit. At least technical discussions have been starting quite a bit. We're also obviously seeing storage being deployed for offshore for the sake of frequency regulation and basically for better control of production and in certain instances also absorption of power. With offshore wind, it can come in big chunks at a time when the grid necessarily wouldn't even be able to take it. And usually offshore asset owners would help themselves by either doing a lot of pitching on the wind turbine blades or even partially shutting down the entire turbine just to not, you know, be in violation and be overstressing the grid. And obviously, again, battery storage is a nice, or could be in theory a nice technology there to do exactly that, but in a different way. And that's again something that offshore developers and asset owners are looking at. And then last but not least, you know, what works well in onshore and solar obviously also would work well in offshore, right? If you could deploy battery storage assets along with offshore for the sake of leveraging peak and off-peak price differences and arbitrage opportunities, that could be an interesting one again. Now, that being said, the last one, typically from what we've seen in first analyses we've done on project, that still asks for a large scale battery. And as you know, whilst prices have come down on battery storage, they're still not at that price point where in all instances the economic case is obvious and is there. So, you know, these are all, particularly in offshore, I'd say early discussions. We'll see more of these projects with offshore turbines and storage being coupled coming, I'm convinced, but certainly not at the pace that we've seen storage, for example, being deployed with solar. Juanita, can you just move on to the next one? Yeah, just quickly talking about kind of the things we've done. We've done a wind storage project in Ireland where we've connected small scale 69 kilowatt, 209 kilowatt hour batteries directly to the converter of the wind turbine. The battery storage here was basically deployed to do certain smaller scale grid services for the Irish grid, for iGrid, the grid operator in Ireland. Those were paid services, or are paid services. So in this instance, the developer, in fact, was able to realize, as I said before, incremental revenues by deploying battery storage. An interesting technology way, the way we've done it here, as I said before, by using shared common converters, so storage as well as the turbine sharing, a common converter. Interesting. I think today we probably see more central placement of storage assets rather than these kind of very distributed placements of battery storage, but nevertheless, interesting project and kind of speaks to the fact that if and when regulation and remuneration is there for storage, developers go and try to obviously grab those revenue streams to enhance their project economics. Juanita, can you go on the next one? And I think I'll hand over now to Juanita to talk about regulation and what we're seeing and observing in certain markets.
Thank you, Amelie. So to talk a little bit about regulation, market rules, and what is required to really unlock the value of hybrids and specifically of wind hybrids. So as we've seen, there is a case for wind hybrids, and a big potential is projected, and this potential will grow in the next couple of years. If we take the case of the US, for example, in the interconnection queues for those ISOs that actually report co-located or hybrid projects such as MISO, CAISO, PJM, and ISO New England, we're starting to see hybrid applications line up. Actually, in the case of the California ISO, what's being reported is around 40% of the interconnection queue is hybrid. Of course, a big portion of that is solar plus storage, but there are also some wind hybrid projects in that queue in CAISO and in the other ISOs as well. So in the US, we're seeing, let's say, orders FERC 841 and 845 already setting the ground rules for hybrid resources to be able to be deployed. But actually, the term hybrid resources is never mentioned in this regulation. So there's nothing specific to how hybrid resources should be treated, even though they're already opening the door to storage to be able to have access to all electricity markets, and through FERC 845 to make sure that storage can be co-located with wind without having an impact on the interconnection capacity. So being able to have an in-plate capacity that's larger than the POI. So what's needed in the case of the US really to leverage the effort already done by FERC through orders 841 and 845, continue the discussion at an industry level involving all relevant stakeholders to make sure that we're actually clear on what the conditions and the rules are for hybrid resources. In the case of the US as well, to wrap up that thought, one of the big drivers for solar and storage hybrids is ITC eligibility. So as we know, storage that's charged from a solar facility is eligible for ITC. And this is not the case for wind hybrids. As we know, wind usually applies for PTC, and therefore we're not seeing, let's say, the benefit of this subsidy for wind plus solar, for wind plus storage hybrids. This could change, however, if there's ITC for standalone storage. This is something that's currently under discussion, and that would definitely help the economics of wind hybrid projects. Now, generally speaking, what is required in terms of regulation for hybrid projects to actually be able to participate or to fully unlock their value is to be recognized as a fully integrated system or a fully integrated machine that can have access to the different revenue streams it provides value for. So the first very important thing is for the operator to be able to make their own economic decisions behind the point of interconnection, and in this sense to be able to optimize the hybrid plant. So as Amelie mentioned before, software and hybrid controls are a key piece of this to make sure that generation assets are integrated at the plant level and that they're operated optimally to be able to realize the most economic value. So that is a very important piece. The second one is to have clear rules in terms of permitting and development, both for greenfield projects, so projects that are being developed as hybrids, or whenever a project that's under development wants to add additional hybrid capabilities, to have clear rules on what the impact is in terms of the interconnection queue, what sort of, let's say, modifications are required to permitting, and make sure that this process is easy as not really impacting the development time of the project. And in the case of brownfield projects or projects that are already under operation and that can be retrofitted with storage, to also have very clear rules on how the permits need to be modified to be able to do this. And finally, and I think that both Martin and Amelie touched on this, it is important for these projects to be able to have access to different value streams. So the capacity to value stack is a big driver of the economics of hybrid projects. Actually, our internal analysis, very much in line with what DNV just showed us, shows that for the case of Wind+Storage, having a single use case or just the energy arbitrage is not sufficient for the economics of the project to pencil out. So being able to have access to the ancillary services market, to the capacity market, with a duration that makes sense, or with no duration restrictions, is beneficial for the business case of hybrids to pencil out. So to close, so that we can move on to the questions, I would say that it is the right time to advocate and make sure that rules and regulations are being developed and can catch up with what we're seeing in the market and the technology, make sure that we can close that gap, and that the industry is having the necessary discussions to make sure that we can unlock the value of hybrids in general, and specifically wind hybrid projects as well. So Reese, with that, back
Great.
to you.
Thanks a lot. Thanks, Emily and Juanita. That was really great as well. Let's quickly move on. There's been a lot of questions coming in, which is great, and both presentations mentioned, and you just touched on there as well, about ancillary services. And DNV went in quite detail about different services, but Roger asks what sorts of ancillary services are envisioned for the future. So on top of what we've mentioned currently, is there anything new that you envision for the future? Martin, I don't know if you want to take that one.
Yeah, I'm personally not the expert on, let's say, predicting the future of ancillary services myself. With that, I'll still say what I've heard within our storage team, basically. So what we are seeing is that there will be, let's say, new formulations of services. So, for example, in the EFR tender in the UK in 2016, I believe that was a good example, which is in principle still a frequency containment reserve, so an existing type of or category of services, but it is much more tailored to a certain technology. I mean, that one was short response time, short duration, with a recovery period. So that is, so we're expecting to see more of that, so that regulation allows more specifically formulated services that are more suitable for certain technologies. That would be at least one answer I would give. And furthermore, I don't think there will be fundamentally different services. If you talk about frequency containment reserve will still exist, frequency restoration reserve will still exist, backup reserve will still exist, but I think the formulations and the regulations around it will be different.
Yeah, maybe Reese, let me just chip in. I think the one thing that we're seeing, only be kind of present in 1 or 2 markets today is black start services. And I mentioned this before, right, on the offshore piece. I think that'll become a bit more broadly spread in terms of something that grid operators will ask for. And it's I'd not call it a standard ancillary service in those markets where, we have, in fact, any ancillary services that are being offered to be done by renewable asset owners or generators or standalone battery owners. So that's one that I see, I think, having still a bit of an evolution in front of it, rather than already being a standard product today.
Okay, great. And I think that moves nicely on as well. You mentioned offshore there. There's been 5 or 6 questions mentioning hydrogen, and I mean, I think that from what we see is quite heavily linked, green hydrogen, to offshore plants. But Michael asks, what is the sustainable argument of using batteries versus hydrogen?
Yeah, it's a question we always get. Yeah, it's a fair question, right? I think there's no argument around hydrogen clearly being more clean, at least so long as we use cobalt in battery storage assets. That being said, I think hydrogen, people still have to get their head around, and more so how to commercialize it and what's the business model that can be scaled. I think the projects that we do see are very much driven by R&D, subsidies, and investments, and not necessarily by economics themselves that pay off for hydrogen in itself. So I hear, and I totally acknowledge the sustainability argument. That being said, with my commercial head on, it's not yet one to be scalable and commercializable all over the place.
Okay.
And maybe a little addition from my side, if that's okay. This, of course, as everybody knows, is also a hot debate and also a political debate. I would say a short summary could be that it really depends on the application of hydrogen. If you're going to use it for, let's say, longer term storage, or you use it for the chemical industry or something, or you make use of your existing infrastructure. For example, the Netherlands has an existing gas infrastructure that with relatively little effort can be converted to accommodate hydrogen, then it's definitely an option to look into. If you want to use it for if you want to convert it back to electricity, or if you want it for transportation, then the efficiency is an argument against, a sustainability argument against hydrogen. There's a power conversion steps there, converting the primary source of electricity, let's say wind, into hydrogen, and then converting it back into electricity, or making it move your car. There's a significant efficiency loss there. That would be an argument against it. So there's not a single answer there. It will probably be part of the energy system for applications that will take that will need chemistry. Let's say the chemical aspect of hydrogen, or longer term storage. And in term where it needs where it's dependent on efficiency and therefore cost, it might be less of an option.
Okay, great. I think we can have time for one more question. And another sort of storage focus, as Jade says, and it's come up in a few of the other questions as well. So I'm just trying to get a topic that covers a few different questions. But we've mentioned battery storage in detail, which is great. What are your thoughts on thermal energy storage? As she's aware, European utilities at the moment are looking into converting coal plants to storage powered by wind and PV plants. What are your thoughts on thermal energy storage? I don't know if you guys have been looking into that at all. Thermal energy storage plants powered by intermittent renewables.
Yeah, I can say a few words on that, perhaps. So within, let's say, within our own team, we focus on electrical energy storage, various technologies. So I don't know the let's say the technical details or the latest on the market. What we do see is that sector coupling, so also coupling, let's say, so not only transportation but also heat with electricity production is in the interest of almost all stakeholders here. So if you have a district heating system and you can convert part of the electricity into heat and then use it a couple of days later, it's very cheap and easy to store, that might be part of the solution. So it is an option in certain locations. If you have a district heating grid, for example, in Denmark, I think more than 60% of Denmark is connected to district heating. There it might actually be a viable option, and there are already many examples there. But if you don't have a district heating grid and you have no use for the heat, of course, it's much less of an option. So can it be part of the future system as a whole? If you look at the larger area, definitely yes. But the consultant's answer will be, it depends.
Okay, great. I mean, I think unfortunately that's all we've got time for. There is a lot of questions still coming in, which I will share with the panelists following the webinar, and you will receive the recordings. And as part of that, I'll speak with the panelists to see if we can get a few more of them answered, along with their contact details, so you can reach out personally. So thanks a lot again to the speakers. And just quickly as well, we are running 2 webinars tomorrow, one focused on solar PV, inverter O&M, and also one on lifetime extension strategies for operating wind plants in Europe. So if you're interested in both of those, or either of those, you can see it on our website, newenergyupdate.com. And in addition to those, next year, we're running 2 really important events for the calendar. Wind Operations Dallas, and PV Operations Dallas, which are co-located events for asset management and O&M specialists. It's in April 2020. I'll send out some more info about that as part of the recordings. But it's been a pleasure to have you all attend. And once again, I'd like to thank the speakers for their expertise and sharing and answering the questions. So thanks a lot, Amelie, Martin, and Juanita. So yeah, that's great. I look forward for everyone tuning in next time. Thank you.